My name is Candice and Moraga, and I'm back in my diabolical laboratory in order to do another experiment today. I'm going to be performing a procedure known as titration, and in this situation, I'm going to be utilizing a mixture of vinegar. Vinegar is actually a solution of acetic acid, and we are going to be doing a process whereby we will be adding a base, which is sodium hydroxide, to a vinegar solution. Now the acetic acid will go ahead and form a chemical reaction with our base, which is the sodium hydroxide. And the result will be water and salt. This neutralization process happens to occur when it reaches an endpoint, which is basically when the number of hydrogen ions, H+, in the mixture is equal to the number of hydroxide ions, which is OH-. This is basically where we find our neutral pH. Now, in this lab, definitely safety is very important. We don't want to blind ourselves after all. There we go. Actually, I think it's a little tighter with my hair tucked in, so maybe we'll do that. And put on the gloves here. Now, I didn't have a stopcock in my lab kit, but I have seen stopcocks and other kits and worked with that and found that it tended to release way too much of the solution. It seemed very difficult, maybe it was just that particular stopcock, but it seemed very difficult to get the solution to drip one drop at a time, the sodium hydroxide solution, that is. In this case, we're going to be utilizing sodium hydroxide, which clearly states on the label that is at a 0.5 molarity. Now, in this reaction, we're using, with the vinegar, like I said, uses acetic acid. We're using a monoprotic acid, which basically just donates one hydrogen. So, in this case, the molarity is going to equal the normality. So, in our computations, I've got the sodium hydroxide's molarity at 0.5. Basically, I have found that I'm sort of better off basically, I've practiced using this little syringe. Hello, I'm back. It looks like my batteries have died once again. As I was explaining, I'm going to be utilizing the syringe to add sodium hydroxide to a 5 milliliter vinegar solution, one droplet at a time. I'm going to proceed to do that until I obtain a reaction whereby I've reached the endpoint as previously described. I will be able to visually see this occurring because I'm going to add a couple drops of the phenolphthalein, which I have used in previous laboratory experiments and explained how it's basically a pH indicator so that we can visually see when we achieve that endpoint, because it's going to turn pink. A very pretty shade of pink, which unfortunately doesn't seem to turn up too well on these videos. So basically, I just had this well plate for stability for this. I haven't opened those yet. I've got this 25 milliliter graduated cylinder in which to measure the 5 milliliters of the vinegar, which I will then be placing into this 100 milliliter glass beaker. I'm going to go ahead and put sodium hydroxide here in this 50 milliliter plastic beaker, and then I will go ahead and draw that into the syringe, notating the amount that I begin with, and then when it reaches the end point, I will notate the amount that I end up with, thereby the difference between the two will give me the volume of the sodium hydroxide used. Now, once I have the sodium hydroxide volume used, and I'm going to know that I've got 5 milliliters of the vinegar, and I know my molecular weight of sodium hydroxide is 40 grams, and of acetic vinegar, or acetic acid, which is in the vinegar, as 60 grams per mole. And then knowing that I've got a 0.5 molarity / normality solution of sodium hydroxide, I can then go ahead and calculate a host of different things for you, including I will obtain the average number of milliliters of sodium hydroxide used for the 3 trials, and then I can calculate the normality of the vinegar, the mass of the acetic acid in grams based upon that, and then I can calculate the percentage of acetic acid using the other equations that I've been given. We will be able to then compare and figure out what kind of percentage of acetic acid is in this vinegar here, unknown percentage. Generally, when you buy vinegar in the stores, the legal amount to label it as vinegar will reside somewhere between 4% to 8% of acetic acid. However, our standard is generally 5%. So I'm going to go ahead and measure 5 milliliters of vinegar into the graduated cylinder. Now I've placed the beaker on a white sheet of paper in order that we may clearly see the results of when it turns pink. We're going to do this titration drop by drop, and we'll know we have reached the end point. That looks to be 5 milliliters. 1, 2, 3, 4, 5 milliliters. I'm going to pour that into the beaker. Recap my vinegar. Now, we'll know that it's reached the end point when the pink doesn't just hit the solution of vinegar and disappear, but when it stays and keeps the whole solution pink. Then we've got sodium hydroxide. I'm putting it into this beaker here, the little plastic one. I'm going to be doing 3 trials, so I might as well get plenty in here, I figure. Might as well. I've only squeezed half of it out. Let me see how much I can get in here. This is a 10 milliliter syringe. I'm drawing a little beyond the 10, and then to get rid of any air and all that, and I'm going to, for ease of calculations, on the first one here, I'm going to make it exactly 10 milliliters. .0. Okay, so I'm going to add this 1 drop at a time and then be able to record the final volume used of the sodium hydroxide in order to reach endpoint. First, we have to add a couple drops of our phenolphthalein to the vinegar so that we can observe the color change. Using this glass rod to stir it. Drop by drop. Aha, it looks like I have achieved. Finally, it looks like that last drop did it. Now let's see if that pink stays there for 30 seconds. It appears to not be disappearing. It does seem to be stable. Let me show you the pink color here. I get some white paper. If you can see. I don't think it shows up too well on this video. Once again, the camera can't see as well as the eye, but you can see in the light a little bit there how it's no longer completely clear. It's a pink color. We ended with 2.3, so the volume was 7.7. Basically, now I just need to do that whole process over 2 more times and take the average volume and then go ahead and do my computations. I hope you've enjoyed this laboratory experiment. I'm sorry that the pink doesn't show up too well other than in person, but I promise you it looked really cool. Peace out, and hopefully you'll like my lab report.